The IGCP is the International Geoscience Programme, and it's the only body within United Nations that has got a kind of remit for the geoscience for the planet. And so it's a body of geologists, of earth scientists from around the world that comes together and gives advice on projects, research-based projects that also have an element of capacity building and education. And they range from studying things that are kilometres under our feet, to studying things up in the atmosphere, to studying volcanoes and earthquakes, to studying fossils and everything. The IGCP has been at the forefront of many of the real big collaborative research networks within geoscience. And it's amazing, considering it only has a very small budget. It actually punches really above its weight in getting people together, particularly young geoscientists, and particularly female geoscientists, and particularly developing country geoscientists together in big projects that can tackle really big, important research questions, but actually with a small amount of money. And it's all about the interchange between scientists in different countries. And it's almost kind of create a culture of understanding geology. Well, I think you just need to look through this. This is the book for the 40th anniversary, and what you see in here is you see a whole set of projects about resources, a whole set of projects about water, a whole set of projects about hazards, and also other projects about life in the past and about what's down there. And I think the point is that it's hard to look ahead to the next 50 years or the next century without realising that most of the absolutely acute issues for our planet relate to the Earth. They relate to water and our use of it. They relate to the resources that we need. They relate to energy, and they relate to hazards. And all of those are fundamentally a geoscience problem. And therefore, UNESCO, I think, needs a committee that will look at that. But there's something else as well, because as well as having a social function for being relevant, if you like, geoscience tells us about the story of our planet. Civilizations and ancient societies should want to be on a tectonic fault line. It seems crazy. But actually there's a lot of sense in it, because fault lines are weaknesses in the crust, and they're pathways for water and gas and things like that to develop. And also they create a fractured, fragmented landscape where sediment builds up and water builds up. So if you go back to the early centres of farming, the Neolithic farming, for example, they occur along the plate boundaries. And then if you go to some of the big civilizations, they occur there. So there's a lot of sense, actually. And the problem is that in the past, where you had cities along these fault lines, they would get earthquakes every few thousand years, but they were comparatively small. Now those cities have millions of people. And so you've got urban targets across the Alpine Himalayan belt, which is one of the big seismic corridors. You have huge urban targets there, and they're going to be struck by earthquakes. So there's a real imperative to understand why it is that people are located, rooted really in fault lines. In the past, there was a culture, or various people have had a culture about how to deal with earthquakes. They'd built for them, they affected their lives. And so the idea is to try and look also at how, through archaeological sites, we can get an idea of how past people dealt with earthquakes, and that might lead us to talk about them today, because today we deal with them through seismic codes and concrete buildings, but in the past people were much more resilient and much more clever about how they did it. So that's what it's trying to do, trying to tease out some of those elements.